Welcome to the Explainer. So, have you ever stopped to wonder how exactly our skin gets its specific color? It isn't just some random wash of paint, right? It's actually this highly sophisticated, microscopic biological assembly line operating right under the surface of your skin. Today, we're going to unlock what we call the melanocyte blueprint. We'll explore the fascinating cellular machinery that actually determines human skin color, breaking down the exact science of pigmentation into super easy to understand visual steps. Let's get into it.
Here's our quick roadmap for today. We're breaking this journey down into 3 clear acts, starting with the architecture of color, then Act 1, the factory, Act 2, the product, and Act 3, the outcome. Finally, we'll wrap up the whole shebang with a quick knowledge check to make sure it all stuck.
Starting off with part 1, the architecture of color. We've got to frame the process to really understand how this system operates.
All right, so our core framework for today is a really handy mnemonic, FPO. That stands for Factory, Product, Outcome. It gives us a really direct, linear pathway to map out how skin color is manufactured from start to finish. If you look on the left, we start with the factory. That's the cell itself. Then we slide over to the middle to look at the product, which is the actual pigment that cell creates. And finally, on the right, we hit the outcome. That's the actual skin shade we end up seeing in the mirror. Factory, product, outcome. Definitely keep that FPO structure in the back of your mind as we go.
Let's jump into Act 1, the factory. This is exactly where it all begins. Okay, so take a look here. Notice how these melanocytes originate from neural crest cells. But where do they actually live? Well, they set up their home base deep down in the very bottom layer of the epidermis, which is called the stratum basale. A really easy way to remember this is to just think of the stratum basale as the basement of the skin. They anchor themselves right down there in the basement, and then they reach these long, crazy branch-like arms upwards into the higher layers.
Now, I want you to lock this specific number into your brain, 36. Why? Because, well, every factory needs its workers, right? And our melanocyte factory runs a very tight, highly specific ship. This brilliantly illustrates what we call the epidermal melanin unit, or EMU for short. In this incredible microscopic partnership, one single factory cell, that's the melanocyte right there in the center, tirelessly supplies pigment to exactly 36 worker cells surrounding it, which are known as keratinocytes. Honestly, a great mental image for this is to picture a giant EMU bird sitting comfortably on a nest of exactly 36 eggs. One factory supplying 36 workers. That right there is the absolute foundational unit of skin color.
Moving right along to Act 2, the product. This is where we look at creating the actual color.
Now this brings us to what's famously known as the ultimate exam trap. If you look at the scale balancing dark skin and light skin, you're going to notice something pretty surprising at the bottom. Regardless of how incredibly dark or light your skin is, all humans have the exact same number of melanocyte factories per square centimeter. Literally no difference. The factory count is completely constant across humanity. So the difference in our skin color doesn't come from having more factories. It comes entirely from the unequal cargo those factories are pushing out. Crazy, right? So if the factory count is totally equal, what's actually driving the color? Well, it boils down to a simple mnemonic. SAD. Skin color makes you SAD. And that stands for size, amount, and distribution. We're talking specifically about the size and number of the tiny pigment packages, which are called melanosomes, then the amount of actual melanin product packed inside those factories, and finally, the distribution, meaning how widely and effectively that pigment gets transferred out into those 36 worker cells we talked about just a minute ago. Let's dive just a bit deeper into that cargo, because it essentially comes in 2 distinct flavors that make up the pigment matrix. On the left side here, we have eumelanin. Now, in biology, the prefix U means true, so eumelanin is the true melanin, and that provides the really rich brown and black pigment predominantly found in dark-skinned individuals. On the right, we have pheomelanin. Pheo essentially means false, so this is the false melanin, producing the yellow-red pigment responsible for coloring in fair-skinned individuals. Your underlying skin tone, it's basically determined by the exact balance of this true and false cargo. All right, let's hit Act 3, the outcome. This is what we actually see on the surface. The visible, real-world result of all this microscopic cellular work is categorized clinically by something called the Fitzpatrick scale. And the Fitzpatrick classification is incredibly straightforward. It's simply measuring a patient's natural reaction to the sun. Specifically, the question is their skin fit to burn or tan when it's exposed to UV light? The whole thing just comes down to that specific ratio. burnability versus tannability. Let's see exactly how this plays out by looking at the absolute polar extremes of this scale, type 1 and type 6. Type 1 skin relies heavily on excess pheomelanin. Remember, that's the yellow-red pigment. And because of this, it always burns, never tans, and frankly carries the maximum malignant potential, which means the highest risk for skin cancer. On the total opposite end of the spectrum, type 6 relies on excess eumelanin, the true brown and black pigment. This skin type never burns, always tans, and offers the absolute least malignant potential. And this continuum here perfectly summarizes the biological trade-off of our pigment factories. Just look at the gradients. As epidermal melanin increases, sliding from type 1 on the left over to type 6 on the right, your skin obviously becomes darker, but it also becomes vastly more UV resistant. But pay attention to that black wedge at the bottom, representing cancer risk. It does the exact opposite. As melanin goes up, cancer risk drastically goes down. Okay, time for section 5, a quick knowledge check. Let's make sure this assembly line logic really stuck with the practice question. Here is your question for today. What is the ultimate exam trap regarding the difference between light and dark skin? Is it A, dark skin has more melanocytes? B, light skin has no melanin? C, both have equal melanocytes but unequal melanin cargo? Or D, dark skin has more keratinocyte workers? Take a second, read through those options, think back to that balancing scale we looked at earlier, and lock in your answer. All right, how did you do? The correct answer is definitely C. Both have equal melanocytes, but unequal melanin cargo. Remember, the melanocyte factory count is completely 100% constant. We literally all have the exact same amount of biological factories anchored in our basement layer. Our unique skin color comes down entirely to the SAD mnemonic, the size, amount, and distribution of the cargo those tiny factories produce. To wrap things up today, I want to leave you with a really powerful concept. The darker the biological shield, the lower the yield of cancer. It really leaves you wondering, doesn't it? When you look in the mirror tomorrow morning, you aren't just seeing a color. You are looking at a brilliant piece of biological machinery that has elegantly adapted to the sun over thousands of years to create the beautiful, protective spectrum of human skin we see today. So, what other incredible adaptations do you think are hiding right under our surface? Thank you so much for joining me on this explainer, and keep learning.
If you find this helpful for NeetPG, hit like and subscribe NeetPgWallah and share this with your study group. And last, also follow on WhatsApp for daily MCQs. See you in the next one.